Lucia?
Ja.
Facebooku bi to mogli že live streamati, tako?
Ja, se že kaže.
Razen da, kje pa to vidimo?
Ja.
Facebooku bi to mogli že live streamati, tako?
Ja, se že kaže. Kaže že.
Razen da, kje pa to...
Okay. So are we all ready? Perfect. I will just copy the link and send to everyone the link to live share on Facebook. And then I guess we can start with our symposium. So I would like to say welcome to everyone joining us via Zoom, and someone is saying that they cannot hear us. Oh, okay, perfect. I'm sorry for this one small technical issue. So welcome everyone. I would like to start with the presentation, Innovative Biomaterials in Design. We will talk about, with our experts, about all the great innovations that are in the fields of biomaterials. And firstly, I would like to just quickly go through today's program. So we start now at 5, and we'll do some quick presentation, welcome introduction, and then presentation about Shemakes project that enabled us to do this symposium. Then I will give the word to our guest lecturers, and at the end we'll have a quick moderated discussion about the future of role of women innovators in the textile and clothing sector, with also possibility of Q&A. So please, at the end, if anyone has any questions for our guest lecturers, you'll be free to engage as much as possible. So at first, I would like to give the word to our acting director, Renata Zamida, to say a quick welcome.
Thanks, Lucia. Yes, active and acting. We're very excited to be a part of this Shemakes consortium. It makes up a great project team, as I have seen, and I'm very grateful that we have Lucia in our team, who is taking care of managing this project very carefully. And luckily, this symposium is online and not on site, since our site is being refurbished at the moment or under construction. Center Rock will basically be located in an ex-factory, the Rock factory, which was quite famous in Slovenia and in the region. It produced very famous bicycles, and today it is the most important piece of 20th century industrial heritage here in Ljubljana. And we can say that thanks to both the way it's being restored and the program of our Rock Center established in last year, its original function will be basically retained, yet a bit revamped. So we will still be a factory with a huge maker space, with a lot of labs or workshops committed to shared use. And we will serve as a public space for the production of cultural and creative industries, with a stress on fabrication, applied arts, design. So it is going to be a universally accessible creative hub, with programs basically seeking to transcend the split between high and popular culture. And since I know that Lucia will take you through the progress also our organization has made in the last 10 years, because it's based on a small pilot project, I will stop here. And I'm very eager to hear the lectures today, and looking forward very much to the results of the Shemakes project that we are all involved in. Thank you very much.
Thank you, Renata. So Rock Lab started as a pilot project in 2012, 2012. And now it's becoming this great open space for production, with production laboratories. I would just like to quickly go through all the exciting labs that we'll have in the future, from cookery lab to textile lab, metal lab, green lab, electro lab, 3D lab, wood lab, recycling center. And we are very eager to start this interdisciplinary approach and invite as much makers and other creatives as possible to join us in this great shared space. First, we are extremely delighted to be a part of the Shemakes project. It is funded by the European Union, and the goal is to empower female and future female innovators of the sustainable fashion industry through the inspiration, skills, and networks. The challenge of the project is, of course, how to elevate women in the textile industry, because they're currently mostly represented in the lowest paying jobs, even though they have the most jobs in the textile and clothing sector. The positions are affected because of the systemic gender constructions and acquired skills that are assigned to low value and traditional business structures. And we are all eager to start changing that. And the solution is to create opportunities and structures and business environments that enable women to move into roles of increasing power and income through the access of hard skills, technology, innovation, as well as networking, business models, and of course, as we will see today, amazing role models that will present their projects to us. With this symposium, we also have an ongoing open call to students to join the workshops that we will host through the Shemakes project. And the workshops will be about the innovative cellulosic and biomaterials. Here I'm sharing an open call and invite everyone who is interested to come and join the workshops that will take place in Ljubljana with amazing mentors and instructors from JAK, from National Chemistry Institute, from Pulp and Paper Institute Ljubljana. So this is open to all students and please check out the open call. And today, now we can go to the main part of the event. I would like to introduce our guest speakers, Anastasia Pistofidou, Pirjo Karianen, Lorena Trebi, Uroš Novak, Mia Sejun, Igor Karlovic, and Matea Benedetti, who will present their research and hopefully inspire everyone to become fascinated about biomaterials and start working in the fields as well. So I'm giving the word to our first speaker, Anastasia, to please take it away.
Hello, everyone. Very happy to be here today with everyone from many different people from all over the world that are innovating and also partnering with the Rock Center for organizing this symposium and also the workshops. I'm very excited. I'm very happy that we can share and co-create this new material knowledge. I am Anastasia. I am a member of IAC Fablo Barcelona, and I have co-founded a program that is called Fabricademy and a research lab that is called Fab Textiles. And you can go to the next slide. In the Fab Textiles lab, we work with different technologies and different implications and applications around digital fabrication, textiles and clothing. So we work with all the digital fabrication, which is 3D modeling, 3D printing, laser cutting, numerical control cutting, different tools and processes and techniques that are innovating the textile and clothing industry. We work also with wearable technology, which is embodying the different senses and augmenting our senses through electronics and flexible wearable designs. We work also with parametric design, so design that is informed by environmental data or external data. And also we work with biodesign, which is the thing that I will mainly discuss with you and present to you today, which is around the new form of designing with sustainable materials, bringing science out of the lab to the world, to the people, and reinventing what we want our future to be around these materials that we use for design. Because we say that if we're using a material that will live for 500 years, but its use is a single use, for example, plastic only for half an hour, then we are wrong by design. We have designed something wrong. So you can go to the next slide. The Fab Textiles is an open source database. So one can navigate in the webpage and can find different tutorials and different experiments that we have been doing since 2012. It's the first textile lab within the Fab Lab network. And it has been always promoting the culture of open source and sharing knowledge. For example, if you go to the next slide, we have developed a database, an online webpage, which is called Open Source Circular Fashion. And it is a platform for all designers to upload digital patterns. You can go to the next slide. And you can download the pattern. You can use a laser cutter to make the different garments, or you can even upload and share your designs. But also, we also promote the knowledge exchange through open publications. And if you go to the next, which is various publications, mainly in the field of how we can create new materials. The first one was in 2017, which is a small publication called The Secrets of Bioplastic. Then it follows the bioplastic cookbook, and later on a smaller publication made from a Japanese intern that was here in Barcelona. So we focus in the green tea bioplastic, specifically oriented to Japan. It is also written in Japanese. And then later next, you can see the main research in food waste bioplastics, the next. So extensive research on using organic waste as a prime source. So we say from trash to gold. You can go to the next slide. With the publication that served a lot for some projects that I will show later on, and looking into waste as a resource and trying to create circular closed loops within cities and villages to reinvent materials. So here you have different contributors that they developed materials working with food waste. And then later on in this research that started in 2019, we created some garments, if you go to the next slide, that are made from basically agar-based biomaterials, and each one has different food waste. So the first one you can see is with apple, coffee, pear, and tea. So different t-shirts made from different food waste and biopolymers. Or if you go to the next slide, you can see the bio-based bag. It is a coffee leather bag, so making different bio leathers. And this is the way we normally publish the recipes. It is accompanied with a step-by-step instruction of how to do it. But also we have different tutorials. And this recipe has been an inspiration for a longer process project that is called Remix El Barrio, that I will explain later. But we don't only work with these materials that I showed already, that they are crafted, the ones that we can mix and make with biopolymers, but we also work with grown materials. And if you go to the next slide, you can see here that we have been working with bacterial cellulose. What is the SCOBY? Others, they know it also as kombucha. So this material has been quite popular in the textile and clothing field due to the innovator Susan Lee. That's the open sourced as well, her recipe. So later on, many researchers started to work on this process of creating leather, vegan leather from cellulose. And also we have later a speaker that will talk more in depth about it. So if you go to the next slide, we did we have conducted research in different growth mediums, like changing the recipe. Instead of, for example, using sugars, we use directly organic food waste so that we don't need to have a prime material that we need to purchase, but how we can change a little bit the recipe and train our bacterial cellulose to be fed from sugars from waste. And then later, if you can go to the next slide, we try different types of finishing. So what kind of waterproofing or what kind of smoothing agent, natural smooth agent you can use for creating this leather, and also how you can color it with different natural dyes. So doing a bath of natural dye with the kombucha after it has been grown. But also how we can design with this material, which is the most interesting part. So if you can go to the next slide, you can see that this material has amazing properties because it can be molded on any surface. It can obtain a three-dimensional form. And here we are molding it on a wooden mold for making a hat. And if you go to the next slide, you will see that once the material has dried, it becomes leather. And also you can see on the right, a laser cut kombucha bag using this modular system that I showed before in the open source circular fashion platform. And all of these bring together this experimentation and knowledge, because we think that we need to be curious about how things are made and what resources they need to be made. And all of these different experiments, they always lead to either explorations and findings or even failures, but learning is always there. We say that the concept of failure doesn't exist. And it's always good to keep on experimenting and trying to also give this knowledge back to the people so that they can go a step further from what you've done. And with this, I would like to introduce the last project that is kind of the longest project that I have been working on, because I have been working since 2019 with food waste, with organic waste, and this came into a very nice merge of as an ecosystem, a co-creation ecosystem for circular local design. And here I say local because it is locally impacting people here in Barcelona, but also it is global because everything has been documented in an open source way, so everyone can follow our recipes and they can create this kind of circular local ecosystems in their districts. So this is the Remix El Barrio project. If you go to the next slide. It is a project that comes with a manifesto, Food Waste Material Makers. And this manifesto comes after a process of co-creation with various designers. And you can go to the next slide. And we incubated, we did an open call for designers to come and work with us and learn with us and work with different food waste. So we worked together in this pilot program that was funded by the European Union called Syscode. And later on, we loved working together and we loved what came out as an impact to our society. So we made a collective, a designers collective that is open to everyone. And if you go to the next slide, this project came into reality through a series of knowledge transfer workshops that we did in the Fab Lab. And then also, if you go to the next slide, we trace and we understand what are the skills that we were able to provide these designers with during this incubation project. And we see that there is a very big diversity of skills here, from biodesign and material-driven design to digital fabrication and craft techniques, but also the open source culture and how to communicate the project, how we can create local ecosystems, and how we can learn about eco and circular design. But even in innovating in the business models that we want to create, how we can make cooperatives or associations, and how we can make more social entrepreneurship. And also getting to know more about the urban digestion and compostability. What is the state in our city, how things are working, where does all this weight go, where does it come from? And then always also looking into service design and logistics. What does it mean if I want to create a circular hub, local hub that processes organic waste and creates new materials? And if you go to the next slide, and this incubation phase ended up with very nice projects, completely different projects, one from each other. So from creating dyes to orange leathers to packaging. And the one that I would like to only talk about, because in this case we are interested mainly also in the cellulosic materials, is the next one, which is coffee paper made from coffee husks. And if you go to the next slide, you will see that we created this coffee husk made paper that was laser engraved. So all the exhibitions from the Remixel Barrio project, they have also been made out of trash, out of organic waste. You can go to the next slide. So different packaging solutions also with using the coffee husks. And later on in the next slide, you will see the different solutions that were made using the coffee husks, mainly an old traditional like paper making technique, but in this case, not using pulp or not using fabrics, cotton, but using some food waste like the coffee husks for making it. And also another one that is very interesting project, if you go to the next slide, is the orange peel leather jacket with the project Squeeze the Orange, that is based on the coffee leather bag recipe. And now the designers, they are working and continuing. The nice thing about this project is that it brought so much awareness and so much, let's say, common vision that everyone continues to work on it and continue to find opportunities and to bring a step further the projects that they came up with. So to end this presentation, and if you go to the next slide, I would like to share with you what we wrote as a manifesto, which is a manifesto that also goes transversally in the work that I'm doing, is to connect with the neighborhood and to find ways to enable local production, to generate circular waste streams and to engage with our community, to think of horizontal systems and co-creation and to democratize the access to technologies and innovation, to think of bringing different experts in order to bring innovation through transdisciplinary design, to make knowledge transfer workshops and open source recipes so that everything that you do locally can have a global impact, and to educate on material cycles and production processes and their environmental impact. And all of this work, it's manifested through my daily practice, and it's manifested through my, let's say, favorite and biggest project, which is also the reason of the existence of the Shemakes network, which is the next slide, which is the Fabricademy network. It is an open and collaborative educational network where we have different places all over the world, and we share knowledge, infrastructure, resources, and we learn together. And if you go to the next slide, and we do this in a hybrid way, so combining online lectures like this one, but also hands-on learning in the different labs. And then if you go to the next slide, and you can see that this network through the years, it has been growing all over the world. So we have various locations where we share, and we love to collaborate with each other and learn from each other, because we think that if we were keeping the innovation in a more closed environment, then we wouldn't be able to contribute for a better world. So these are a few projects that I had selected for the talk for today. Of course, I wanted only to show some of the bio-design, but of course we look into the design from the different aspects and also how to integrate these new technologies in the design. And I'm happy to give the word to the next speaker.
Thank you, Anastasia. I would like to invite Pirjo Karajanjan to start her presentation.
Thank you. Thanks for a very interesting presentation, Anastasia. It's always so inspiring to see your work. My name is Pirja Kääriäinen and I come from Finland. I work at Aalto University as a professor in design and materialities, and I've been working with this ChemArts collaboration between School of Art Design and Architecture and School of Chemical Engineering since 2011, but I will tell a little bit of my own background later on. But please change the slide. Yeah. So the ChemArts is, as I already mentioned, it's an educational collaboration inside university. So it started, not as an open activity. It's more like an educational inside our curricula. And it also started by using the laboratories at the School of Chemical Engineering. So bringing in this scientific approach very strongly from the beginning. And later on, we got our own laboratory for more like design studio type of place where it's students are more free to work together with these materials. But the collaboration has initiated, it has grown also to several other levels, for example, to research projects. ChemArts cookbook we also made 2020, and it contains mainly cellulose-based recipes also for anyone to experiment with. The problem is sometimes that some of the materials we've been using are pretty difficult to get in the hands. So that's of course one thing that sometimes everyone who wants to work with these recipes is not able to do it at the moment, because we get several of the ingredients are coming from the paper and pulp companies and forest industry directly. But we have had from the beginning plenty of enthusiasm, and I've been working there with my colleague Tapani Vuorinen, who is professor in wood chemistry, so with a completely different background than what I have. But our activities are really, we try to be as student driven as possible and give, we want to cherish freedom and openness in whatever we do. But as we work in these laboratories inside a School of Chemical Engineering, it means that we also need to follow quite strict safety rules. So we are not totally open on that sense. Please change the next slide. In general, I think we have the three main aims and the benefits that what we see here in our work. It's first of all, it's giving hope for young people and also young researchers. We have so many problems currently around us and so many the climate change and environmental problems. So one way is to, when people are able to work with these materials, they feel reconnected with the nature. So giving hope, that's very, very big part of our work. Another thing is this sharing inspiration and knowledge, as I already mentioned. So we try to raise awareness of where the materials come from, how they should be used during when we are using them, and then of course where they end up after the use. And if we really want to make the change, which we are of course working for, all of us, for a sustainable future, we need to increase the awareness of these materials in general. So unfortunately, too many designers don't know where things come from. And that's really a problem, because how can you design something new if you don't know where what they are currently? So that's something that we try to spread. And by the way, in the image is a very nice project here in the center. It's this elder project by one of our master students. She cut one tree from her family yard, and wanted to use every piece of that tree and ended up in various kind of material experiments there. On here you see also when we really want to make the change, then we need to collaboration and communication, intensive networking, and like Anastasia was showing, all those capacities and competencies that we need to learn and utilize. We also need to have this courage to fail, and we need to be super persistent to take things forward. The next slide, please. As I already mentioned, that on education we work, our students work a lot with this experimental side, and but I wanted also to raise up this how to move from ideas towards innovations, and this is from Nesta. There are Nesta. This innovation spiral. There are several other types of ways to show how these things. It's kind of a roadmap from ideas to the real life, real use. And if we think of our ChemArts activities and these student work, they are mainly on these levels 1 and 2. So it's about opportunity mapping and experimenting and generating ideas. But for example, I've been working with this textile, ion cell textile fibers now about 10 years. So it really is a long way to go. And maybe that's now on the level 5. So it's still in progress, not commercialized yet. And sometimes I'm also involved in fundamental material science projects, and then they are not even on this map. They are somewhere on the kind of a pre-innovation activities. So before we as designers are able even to think or imagine what could come out of those. So it's so different levels on this material experiment world currently and material research world. Sometimes it's good just to figure out what is what and where we are with these ideas. Next slide, please. So I want to also say a little bit about the collaboration, because that's when you want to move from the ideation forward, you need to have this collaboration. It's crucial. And it needs to be interdisciplinary or cross-disciplinary. And you need certain skills to be able to collaborate. So you need to have this curiosity, you need to be able to listen. And first of all, you need to have the willingness. And it was nice to hear, like Anastasia mentioned, that they enjoyed in one project so much to collaborate that they continued even after the project ended. So that's super. It's so nice to hear. And these teams need to have also somehow shared values, but also the responsibility, of course. And it has to be open, co-working, co-learning, and mutual interest. But it's also the practicalities need to be agreed in the beginning, whenever you are collaborating. So questions about funding and IPR and crediting. So fair crediting is something that is crucial, whatever you are doing together. And of course, people working in scientific material science, publishing their research on those channels, they have a little bit different systems that we as designers, especially if we work on this open end of these innovations and design activities. Okay, last slide. I think it's last. Yes, that's more about myself and why I ended up here talking to you today. So my background is in countryside. So I come completely a small village, Finnish, middle of nowhere, maybe almost in Finland. But I have had a wonderful freedom to move around in the nature, play with the nature, play in the nature. So it's something that I carry on me all the time. It's very important part of me. And now after I have been working with these materials since 2011, that knowledge, tacit knowledge has become even more important to my own work. I had a career before coming to academia. I used to work for textile industry. So the big scale systems, kind of and how things move forward on a big scale production. I'm pretty familiar with that as well. what has happened during in my career now at the university, I had to put one of these highlights here, because I was part of the team of this. We received this first HTM Global Change Award 2016 with the Ion Cell team. And as you see, there are my colleagues here, three great male researchers also. And I have to say that I have been extremely lucky to be able to work with these in some cases, they mostly are males, but I have to say that we have plenty of females as well here, also at the chemical engineering. So it's something that we just need to work for, and we have to. I would love to have a future when we don't need to think who is male and who is female, and we just can work together and do interesting things, whatever it is about. And then just to finalize the talk with this Michelle Obama's quote saying that there is no limit to what we as women can accomplish. And now, of course, that's here in Europe and in Scandinavia, it's already almost true. We still need to work a little bit more, but we have all things are open for us as females. Thank you.
Thank you, Pirjo. What a wonderful presentation. And now I would like to give the word to Lorena Trebi to continue.
Thank you. Hi, everyone. I'm really thankful to be here and also thankful for the previous presentation. Today, first of all, I'm going to introduce myself. I'm now a postdoc researcher from Sapienza University in Rome, in Italy. And today I will talk about my PhD research, which I carried out over the last 3 or maybe 4 years. And you can go to the next slide. So my research project investigated in general how the biofabrication revolution is affecting the design culture, and how, on the other hand, designers' approach and methodologies can affect the way biofabrication spreads and permeates our society. So in particular, one of my main research questions was understanding which is the specific role and contribution of designers in fostering the diffusion of biofabricated materials, also bypassing the long lead times that usually characterize the industrial development of new materials. So I started by analyzing and mapping all the emerging trends in this field in order to envision the future perspectives from the point of view of future materials, design researchers, and also future industry, and therefore future production consumption systems. You can go next. Okay, in particular, in the experimental part of my research, I focused on microbial nanocellulose production and fermentation. This material is the byproduct of the fermentation process of a symbiotic culture of bacteria and yeasts, better known as SCOBY, and is a process which is traditionally used for kombucha production. So you can go next. Okay, so since working in between design and biology, it was fundamental to acquire methods and approaches from science without, however, never substituting them to the ones of design, but rather trying to hybridize them. This because it is fundamental to establish precise steps and protocols to follow as happens for the science investigation, but it's also essential to address them with a design-driven approach, which means guided by creativity and induction and invention. So the methodology of my whole research was grounded on the central role of experience, and therefore on the approaches of learning by doing, experiential learning, and action research. And as you can see from the slides, the methodology I used in my experimentation was characterized by an alternation of different stages of experimentation and evaluation, where the main evaluation tool were represented by our own senses, so by our body, and narrowing the field of investigation going further through the steps. So the path followed during the experimentation was characterized by a continuous exchange between making and thinking, since I think that theoretical reflection, of course, arises from direct experimentation, but is also necessarily to go back to experience in order to be validated. You can go to the next one. Okay, so I started my experimentation on microbial cellulose, starting from a sensory exploration of this material, interacting with this production process. This because the aesthetic perceptual properties of materials in general deeply affect the way they are perceived and can therefore determine or not the appreciation from the user's point of view. So I started interacting with the kind of nutrients and kind of food used to feed the microbial metabolism, which affected, first of all, the color of the material, but also at the same time, all the other organoleptic properties, such as, for example, smell or surface texture. So I explored the whole color spectrum, which is in this case not some just an ingredient that you add to the recipe, as happens, for example, for most bioplastics, but is determined, of course, by the kind of food that is actually appreciated by the microorganisms. So I had to learn how to work with it. It was some kind of co-working experience with microbes. And beside the color spectrum, as you can see, I explored also the possibility of making, producing white transparent nanocellulose. So after this stage, you can go next, please. After this stage, I also experimented with the processing stage. So using tinkering and manipulation of the material in order to observe and understand its behavior and its characteristics, or as Ashby would say, it's the material hidden character. So I identified some processing techniques that could be used, both with the wet material and with the dried finished piece of material, in order to affect and interact with the different sensory properties. You can go next. So as a result, all the material samples were collected in a material archive in order to illustrate the broad spectrum of possibilities for these materials in terms of sensoriality. You can go to the next one. And as you can see, each sample was put together with a sort of sensory evaluation chart in order to describe this point of view of the material. And you can go to the next one, please. Okay, so after this initial experimentation stage, I started analyzing the material properties which emerged from the experimentation in order to identify 3 macro application scenarios for this material, paying attention to the fact that the material properties should represent in this application an added value for the product rather than, for example, a weak point, as could happen for the very short lifespan of this material, or for example, its high hydrophilicity, which makes it particularly sensitive to the environmental condition, for example. So the first scenario was the one of augmented paper, because microbial cellulose has many common characteristics to traditional paper or vegetable cellulose, plus some extra features such as the translucency, the flexibility, or also the self-adhesiveness, which makes it a sort of augmented paper. I made also some printing tests collaborating with a letterpress printing here in Rome. I forgot to say one important thing, that all my experimentation was carried out, started in WAG in Amsterdam, in the Netherlands. And then after all the lockdown that we had a couple of years ago, I continued my experimentation here back in Rome in Saperi & Co laboratory that we have here in Sapienza. So the second application scenario is the one of sensory packaging, which can be embedded with some synesthetic features, because it can be self-produced, for example, using organic waste. So some food and beverage company could potentially self-produce their packaging, also embedding and communicating all the organoleptic properties of the food or beverage contained through the packaging from the external point of view. And finally, the last one is the one of skincare, because the material is 100% biocompatible, and it is also already used in the medical field in contact with living tissues. And this, plus the wound healing properties and its high absorption ability, makes it particularly suitable for example, the making of different typologies of patches and bandages, which can also be embedded with the medical or dermocosmetic treatments. And also, of course, it can be applied in the whole field of solid cosmetics. As you can see, I have to say that I'm a product designer, so I've been working on this material from this perspective. And despite this, as also Anastasia has told before, this material has been often proposed as an alternative to animal leather. I think that we have a lot of new possibilities for a vegan leather that could substitute animal leather, and maybe this one is not the most advanced because it requires a lot of working since in its natural form it is very, as I said before, very sensitive to water, humidity, and environmental condition. So it is quite ephemeral in the lifespan. However, it is important also to remember that beside the everyday clothes that we wear in our everyday life, there is also a huge part of, for example, the theater performances, shows, and different kind of scenarios where the clothes, costume, and accessory are used for a really short period of time that can go maybe for one night to a year, for example. And in this particular scenario, I think that this material could perfectly fit with these features, also including its short lifespan and for the application as a textile, for example. You can go next. Okay, so finally, after exploring the material from the nanoscale of processes and the mesoscale of products, I finally shifted to the macro scale of production systems in order to try to envision future prospects for the development of a diffuse microfactory for nanocellulose production. This started from the idea that maybe we as designers have the opportunity also to trigger some bottom-up processes instead of just trying to insert the material in the standard industrialization stage, in the standard industry that we have today. And we can also, this can also represent an input to start rethinking our production systems, for example. So I started this stage by a collaboration with a kombucha brewery, which was aimed at completely circularizing their production process, reusing so all the kind of waste and byproducts that were available in order to use them as a food for the fermentation process and allow them to self-produce, for example, packaging and other nanocellulose products. Then the second step, you can go to the next one. So the second step, I designed a fermentation toolkit in order to allow the replication of this micro production system in order to work as an enabling tool and supporting co-design practices. And the toolkit was consisting of a cookbook collecting all the recipes and processes to follow, some brewing tools to use during the fermentation process, and also some processing tools to work with the material after it was harvested. So finally, the third and last step of this process was using the toolkit in order to horizontally scale this production system and expand it not only to the kombucha breweries, but also to other typologies of food and beverage companies. And of course, selecting them according to the kind of waste they produce and selecting the kind of nutrients suitable for the fermentation. And also connecting them together with some local retailers that could be interested in the sale of nanocellulose products according to the application scenario described previously. So this was an attempt to show that instead of waiting the long time required from industrialization, we have the opportunity as designers to make these materials also available to people through everyday, very simple everyday product. And in this way, we can also foster a sort of familiarization process and this demystification process towards biomaterial innovation and biofabrication in general. So to finish, I think I have my last slide. Okay, I want to just go back to my initial research question, which was, which is the specific role of designers in this transdisciplinary field of biomaterial innovation? Because of course, We are working together with the scientists, and we cannot try to just do poorly what other people can do better. So it is fundamental that we are aware of our specific contribution that we can give. And I think that we can see how designers are able to act as a sort of synthetic element and therefore shift from the micro to the micro scale. And in this way, using what Ezio Manzini defines as fundamental tools of the designer, the microscope and the macroscope, so to shift among scales. In this way, we have the possibility to grasp all the interconnection and make visible the overall plan, overcoming in this way the specialisms and the partial views they can provide, so working together. This because I think that if we want to bring structural changes rather than just providing symptomatic solution, we need to, of course, referring to the global and environmental crisis that we are living today, we need to match the technological and scientific side of the biofabrication revolution together with a cultural revolution. Otherwise, the risk is just to repurpose a new materials or a new technology with the same wrong attitude of the past, which was responsible of the crisis we are living today. And so it is up to design to work on this cultural side of the material innovation and learn also how to communicate the transitory and cyclical nature of matter on the planet, and as well as the value of imperfection opposed to the aesthetic flawlessness and standardization which was brought by industrial mass production. In this way, we can counterpose the idea of evolution and circularity to the idea of progress and linear incremental growth, and maybe helping through this cultural revolution to shift from an exploitative and parasitic attitude which has characterized human activity worldwide so far, maybe to shift towards a more collaborative and mutualistic attitude aimed at co-creating together a symbiotic future. And with this, I finished. I give the word to the next speaker.
Thank you, Lorena. Next, I would like to invite Uroš Novak to give his presentation.
Thank you, Lucia. Thank you for having me. Hello, everyone. So I'm Uroš Novak. I'm a chemical engineer by profession, but for the past 5 years, I'm working as a coordinator of the Scientists Against Plastic platform, which fosters collaboration between scientists, designers, architects, and business actors. We are working on 3 fields, trying to fight the plastic problem. One is the cosmetics, the second one is the packaging, so the food, and the third one is fashion. So far, we will be establishing 2 startups in the fields on cosmetics and in packaging. This presentation will be now trying to present what we are developing in the fashion branch. So let's see our next slide. But I would like to have your participation. So in the next 3 slides, I would like that you give me your feedback. There will be a link in the chat. Please click it and go to the Mentimeter. And this is how you will give me your feedback, and then we can discuss. So first slide, it's about truth or lie. Because as a male, which is obvious, and we try to go from the lab to market, which is our goal as a scientist, and our Science Against Plastic platform. Lucia, there is still no link in the... people are starting to sharing. Okay, so the question that you mainly get to prove that this material that we are developing, we're talking about innovative biomaterials, come to the market, are always quite the same. So always is comparing towards plastic. So biomaterials won't biodegrade in a landfill. Is this true or false? Usually it's something in between, but what people perceive. At the end, you will see the right answer. Biomaterials are more expensive This is something when you're approaching to the market, it's very important questions. Biomaterials do not last long. They're biodegradable. And the last one, biomaterials encourage people to litter more. Okay, 9 persons participated. Let's see the answers. Lucia, please press enter. So, as you can see, people believe that they are like it's a lie, yeah. So that they will biodegrade in the landfill. The truth is that are more expensive. You can see it all the time. Also, if you compare just plastic and leather, do not last long. That's true. Someone before, the first speaker said, yeah, 500 years to decompose or to remove plastic. If you compare to the plastic, they do not last long. And that's the point. Encourage people to litter more. Still, you can see that we are not on the same page. But my opinion is it depends on the person, not on the material. Next, here is the question. Innovative biomaterials should have the same properties as conventional plastic, be cheaper than plastic, possess new features other materials do not have, be circular, or be zero waste. Let's see the voting. And here you can change from strongly disagree to strongly agree. Okay, we're getting some results. That's good. And this is very important feedback that you learned for the past 5 years from working on that. You know, to work as an engineer, as a designer together to see which pain we need to fill. So being cheaper than plastics means, okay, I will show some example later in the 2 business cases that we developed. But as we can see here, be circular is something that this audience here really agree that should be. So this is also which I agree strongly. Zero waste also. Others, let's see. Let's see on the real life examples that we made in these presentations, in the next slides. So the final one, the question for you is, which feature would you add to the clothing biomaterials? You can just choose one. So self-cleaning, that means that we do not produce microplastic during washing and so on. Breathable and stretchable, provide psychophysical well-being. This was meant that you get different properties other than this visual one, so for touch, smell, and so on. For example, one of my designers said that if I'm nervous and want to go to some meeting, how can my material, how can my garment or my clothes help me to be more confident? So she developed a concept to add different properties to the material. Depends on the properties like smell to provide there with better energy. No one decided about that. That is true. We have a exhibition, and this was too extreme at the moment. So no one wants to have the smell, for example, the etheric oils and so on, to the garment, because it's not, we're not used to. Usually we put on ourselves. Breathable and stretchable, self-cleaning, recyclable. Okay, so I somehow remember those results, and now we will go to the slide that I prepared before. So your help was greatly appreciated. And yeah, so as said before, I work in Scientists Against Plastics. So plastic, it's a problem. And this is how the society see how we can deplastify our life. But you will, if you will be like me, for this will be too hard. It's such a lot of stuff. So what we did, we tried to simplify stuff. So in this talk, I will just focus on the clothing material, on clothing biomaterials. Let's forget other, but you can see, you can find other solutions in our webpage, Bioplastic-Free EU. So where we have developed different solutions to all of these problems. And 2 are already on the market. Next slide. So usually they want to put you somewhere, are you plastic, are you bioplastic? But we try to be something else, because plastic and bioplastic is not good enough for us. You have to be something else. And biomaterials usually are biopolymers. Zero waste, that means that if you get bioproduct, what you can decide that you don't have any waste. What does this mean? No one have to take care of your product at the end. So you can dispose it, you can reuse it, you can repair it, and so on. This is the logic. And this is the logic of biopolymers. So to the next slide. And this is the click. Okay. First business case is upcycling fruit waste. You all heard about fruit leather. There are different companies doing that. So idea here was to use some material which is quite abundant in Slovenia, and apples was one of those. For all this process, we didn't spend any money because the apples was from my orchard. This was from Lucia's dad when they're making apple juice, and from the friends from the Institute of Celluloid Paper, we get cellulose. Okay, there are some different other small details that we added. For example, natural based coloring. So all these colors you can get in nature. Nothing here is artificial, so we don't have any blue, any other colors. How far we came, the next slide. That the students, you can see here in the image below, can already in our lab developed different casing for the sunglasses and so on. We have different accessories, booklets like this, and other stuff. So it's quite simple, straightforward, and still it's not on the market. Why? Maybe we can answer this in the question and answers part. And for the second one, second business case, here, student from the Faculty of Natural Sciences Engineering came to me with the idea for their master thesis to design her own biomaterial. What we also did, we promote young entrepreneurs, for example, especially female entrepreneurs, to talk about their story or vision. Here is on the left, you can see what she wrote. So strongly dependent on fashion, but she lacked the knowledge in the materials. This is where our lab helped her. And now I hope she will join my team, working on her PhD on biomaterials, working on her startup called Vivre, and be passionate entrepreneur, since you have skills that we don't have. For example, she made those clothes, and her vision of the future, this collection is the vision of the future, is that clothes do not belong to man or woman, but are equally for both. All of this collection can be worn by man or woman. Next slide. Besides the clothes, of course, the vision of the future also have a lot of other stuff. So the same material, same logic. And here she developed different types of solutions, which do not just have the the option to carry stuff, but also, for example, in the pink gray pack, you have this additional, like a pillow that you can just sit on it. Then you have the belt with the bags and so on. But not to get into details, since I'm not a designer, I'm passionate about the materials. You can go to our web page. You will see here, bioplastic-free solution of fashion. You will see all the details about it. So to finish with our values, sustainability in the fashion, it's not good enough. No one really cares about it, so we have to go beyond. So leave the planet in better shape than it was before that we inherited. Biodegradable, of course. Plant-based is something that all my students prefer. So no leather, no other animal-based products are used for the development of the textiles. Reusable and zero waste. That means that the material should not be thrown away, but the material should be worth something, and closing the loop in the local communities. All the materials that we shown are based on what we have in Slovenia, in our local communities. And the idea of all the students that are working is to have this closed loop for the community. So you bought expensive coat, the material can be then reused, sent back to us, and so on, without using more virgin materials. And this is what we can do with the eco design and working on the materials that we developed. So all these materials have this already in place, because when we developed, we have this vision. And with that, I would like to conclude that I really enjoy working on the solution that are brought to my attention by the female scientists, female designers, since I was not aware that this is even that much of a problem. That's true for 50% of the world population. We don't care that much as female does. So, thank you.
Thank you, Uroš, and thank you for that exciting poll. We will definitely discuss the answers at the end. And since we were talking about teamwork and collaboration, I would like to invite Mia Sejun and Igor Karlovic to present the next lecture.
Hi everyone. We agreed with Mia that she will be the boss and I will be the talking to empower Mia and to help her through this presentation. I shall present briefly in our 10-minute slot where is our institute as a classic business-to-business institute previously during the history, how it transformed itself to more sustainable and circular stories, where we engage in different projects from young startups, young entrepreneurs to big businesses. And I think that is a very good starting point in empowerment of young people, that we have a very good network of connection in scaling up, because lot of young designers need a helping hand in scaling up, because idea is the first step, but again, you need some technical support to go to the next level. So please, the next slide. Okay, as we all know, our name is a very classic one, Pulp and Paper Products, and everybody, when refers to us, is thinking just about paper, but paper is, yes, one of the main products from cellulose, but there is a wider range of uses, for example, in textile, foods and biomaterials, also flexible materials, and more recently, more and more people are using trees as a kind of omnipotent biomaterial for biochemicals. in the so-called biorefineries, and the paper industry is turning into biorefinery industry, where different size streams can be used, as I said, for cellulose. They can be used for different kind of lignin and other applications. I will mention it in a few slides beyond. But what's the most important, that this industry, which is a classic one, is changing, and it's very compatible with the new biomaterial revolution, which is happening, as I see, throughout Europe. So please, next slide. Okay, what is our specialty, or what is special with the ICP? We are looking for very unusual sources of cellulose, and that means that we are looking for different kinds of agro residues, industrial residues, and also I think we are among first in the world who are using invasive plants. What are invasive plants? Because this is a specialty, because we already did a lot of products, a lot of projects with invasive plants. They are plants which are brought from a different continent and are spreading and killing the local biodiversity. And that's why they are called invasive plants. Of course, it's a little bit of interesting topic, because some of the invasive plants have very good properties, and then they can bring very good things like detoxification of soils. But again, if we talk about biodiversity, they tend to spread to very fast, and basically take out the local biosphere. So regarding lignocellulosic biomass, we are doing with all four ways of which you can go with the lignocellulosic biomass. We are doing with cellulose fibers, as I said, from different sources. Then we are also working with hemicellulose. Recently, we are working a lot of with lignin, and also we are doing with extractive. So when you think about your idea as a young student or a young entrepreneur, there are a lot of plethora things that you can mix from one biosource. So it's not just the fibers or just the lignin. For example, lignin starts to be very interesting in biochemical production or adhesives, and a lot of companies are looking into it. And also maybe you can use it as a glue for your designing projects. And the problem is just that you have to use some kind of chemicals to extract it, because basically lignin is something which holds the lignocellulosic or the wood together. But it has very, very good applications, and many industries are starting to treat all these extractives as some kind of added value material. So it's not just cellulose. We can go one step further. Okay, how we work, or one of the main input raw material characterization step is we first determine how much cellulose, extractive, ash content, or lignin is inside the sample, because it is something we noticed with different startups, that they have the idea, but they lack the knowledge about their materials. And if you want to engineer, also bioengineer, you can go by trial and error, and it can take you a lot of time to find the right mixture solutions. But if you know what's inside, then you can decrease this engineering time very quickly. And we have a database with over 60 or 70 biomasses, very unconventional ones, from agro residues, for different husks, for different side streams, from bakery products, from different kind of fruit production, fruit processing, where we have very exact amount of these materials. Why? Because basically the cellulose content, ash content, lignin content determines your mechanical, elastical, and all other properties. So you can play, but if you know what kind of Lego bricks you have in your hand, this play can be much more productive, and you can move more quickly into the market or with your idea. So we can, for example, support all young entrepreneurs with this kind of analysis. We can go one step further. Okay, so if you want to collaborate with us, you will come to our so-called creative green funnel. What that means, you bring the light bulb, you bring your idea, and what can we offer as a support? We can do the chemical and morphological analysis of biomass. As I said, we will take apart your biomass you brought, and we will do the whole characterization that you know exactly with components you can play, what to combine, what is mixing, what is good, what is too much that you have to wash away. Then we have a lab prototyping facility where we can make lab sample handsheets, we can coat it, we can do some 3D modeling, we can do mechanical testing, and also if it's, for example, for packaging, we can do the food contact testing. What is very important, because a lot of biomaterials, if you have direct contact with food, you have to be very, very sure, because the regulations are very strict. So it's not very playable if some of the components is transferred inadvertently to the food. Then if you like your idea, everything is okay, we can help you with your construction, design, printing, die cutting, mechanical testing, because we have a pilot prototype machine. That means we have a pilot or a craft paper machine in heart of Ljubljana, which is big enough to impress you, but small enough that we can play with single designers. So it's a kind of oversized toy for playing, but also it can make few tons a day. So you also can make a small series of your product. Also, we can do biodegradation and composting testing with all the standards. So you exactly know how much or how long this product, if it's a textile product or it's a wearable product or it's a packaging product, that it can last, and will it biodegrade if you, for example, add some plasticizers or some things that it hold it together. And when you're ready with all this testing, you can step up to make a market-ready pilot small series where we can help you as a young designer, that we print it, convert it, cut it, and we can give you a whole certification of compliance. So basically, we act as a one-stop shop. And that is a very good business model, because I can say that a lot of startups who are doing bacterial nanocellulose from Poland, Denmark, Italy, they're coming to us because we can give you this whole chain that you exactly know what you have, and you also can have a kind of a prototype in your hand. And we also have done this for small startups, and we also have done, for example, for Nestle in the last few months. So we can work with big guys, and we can work with small guys, and we like to work with everybody. Okay, we can go further on. So what can we manufacture, or what kind of machinery we can offer to young designers with ideas? We can do your material in form of paper or non-woven rolls and sheets. For example, some kind of thick material, we can dewater it, we can add some starch or some kind of different binder. We can do it in different thicknesses. We can do rigid structures, for example, cardboard or corrugated board. If you have some, I don't know, shelling around your design materials, we can coat or innovative cellulose applications on textile, on other web materials, for example, biochar. We also did some coating of lignin on textile webs or paper webs, so that is also a possibility. We can do molding, and also we can cut it over print and even make it digitally responsive because we also have knowledge on printed electronics. So we can make also bio-wearable electronics, where we are applying in projects where we are not using silver inks but biochar inks as a laying ground to connect the electrical components with, for example, biomaterials, that everything comes from biosources. Okay, we can move on. Okay, so what is the infrastructure for manufacture? The main picture is missing from this presentation. Aha, here it goes. Okay, as I said, we have a pilot paper machine which can produce non-wovens and it can produce papers. And we are using, as I said, for very innovative mixtures. I think somebody from Spain, I think, mentioned coffee ground paper. We also did some coffee youth bags paper. We use tomato stems. We use, as I said, invasive plants. We also used hops. We used different kind of biomass vases, sawdust from wood mills. We also have used some fruit samples in the paperware. So we have, I think, a portfolio of over 15 kind of different papers or paper type materials that we tried and tested, because this machine is open to see and play, and you can mix it almost by hand, adding some of the components. And also regarding converting, we have the coating facilities, cutting, printing, where we can print and basically process 3D materials up to 30 centimeters, which are already formed, and we can apply printed electronics or classic printing with bio-based inks or anything. So I think it's a good support for young people if they want to collaborate with us. We can go one step further. And one step further. This was just the picture. Okay, and just to end this short presentation, as I said, we are open to everybody, from big companies to one-person companies. We have a lot of experience in international collaboration, especially with bacterial nanocellulose or using temp oxidized nanocellulose. And also we have helped a lot of students in their applications, and we are really enjoy in helping and growing new green circle solutions. And we like to say that let's close this circle, green circle, together. So I'm inviting everybody to contact Mia or me, and we will be more than eager to help everybody. Thank you for your attention.
Thank you, Igor, for this wonderful presentation. Next, I would like to give a word to Matteo Benedetti, who is an amazing and extremely achieved Slovene fashion designer, to tell us about her brand Benedetti Life.
Good evening. First of all, thank you for everybody, because this is how it starts. And I have to say that all fashion designers, for us, materials are never enough. So more we have, more we are happy. How you will see, the first problem that that was when I start working in sustainable fashion is that I didn't have enough materials, enough to create beautiful garments. I established Benedetti Life a few years ago with this purpose to show what innovations are on the market ready for a production, for a real production for garments for the market globally. So we know everybody that fashion has now, let's say, one important role, and this is how to do this transition from linear to circular. And we are in quite strange times, because greenwashing is at the same time going on with all these innovations. So for us designers, it's very difficult to understand what materials are really biodegradable, what materials are really circular, and that we don't buy something that is just written with certification, but behind we don't know how it was made, because to the end, to the textile and to us, it's a long way. I will, maybe we can go on the first slide. What was my purpose? I want to create a luxury brand that use innovative, sustainable textiles that came on the market. So my first one of the materials, let's say, I love to work is pineapple leather. But I will tell you at the end a little of my history. Why? Because when I move from sustainable fashion to sustainable and vegan fashion, the biggest problem was how to find sustainable leathers. And still it's a huge problem how to find warm, sustainable and plant-based materials. Because for winter is still a problem. I can use it, for example, from recycled plastic bottles and so on, but they are not warm materials. So I think for all developers and scientists, it will be maybe in future even a big challenge how to create sustainable plant-based and warm textiles. This is the gold skirt is made with pineapple leather. I am working with Pinatex a few years, and I am even in contact with them because when they launch something new, I want to be one of the first to try to experiment with this material if we can make garments that we can put in production. Next slide, please. Here is an example of what was, for example, one challenge I have in fashion was how to make gowns, evening dresses, wedding dresses, more luxury, let's say, dresses, blouses that looks like silk, but that they are plant-based. So when it comes to the market, of course, tencel and enca viscose and these all materials that I made with wood pump was for me, let's say, a huge step forward in design, because designing with a very high criteria garments that are made for production, it's quite a challenge, because still even we don't have enough, for example, colors. Each material you have to color separate huge quantities, no, to develop quite, let's say, on a high level design. Even the problem is with patterns. We need to do all the patterns ourselves and to make it in factories or to put it in prints in Italy. So here, as a sustainable designer, it's, let's say, it's a huge work in development and it takes more time, but the fashion, it's fast. So for us that we need to make, I don't know, maybe even some brands make 24 collections per year. It's very difficult to conquer that market. I have to change my mind. I have to decide that if I want to work in this way, I have to have my rules. And I think that here all who works in this segment in how to change things that will be for people and for our future and for the planet good, we have to change old habits, old mindsets, and we have to move forward and start thinking really more about the planet than about ourselves. Next slide. Here is just an example for those who don't understand how some materials are made when you, let's say, from forest to wood, and then they get cellulose, and then they do a fiber and the yarn, and then the textile. So I am, let's say, what I do, at least I check yarn, and this traceability is for me very important. So from the companies that are producing textiles, I'll try to get lots of information, what is behind, from where the source, where is the source. Sometimes it's quite difficult, or they don't want to give it, or it's quite, let's say, impossible, but where we can, I do. What takes, again, the process of designing sustainable clothes, it's a little different than normal fashion. Next slide. Here I put if the first two material are made for natural sources, so from pineapple, which is waste from the food industry, and it's made with pineapple leaves. Then the second, it's made from wood. This one, I want to create, I want to show that haute couture dresses you can do even with waste, but truly waste. We take really old plastic bottles and we cut it hand by hand and sew it hand by hand, each pieces, because in sustainability, it's still difficult to get these shiny effects. So I do it with waste. Next slide. This is how I start working with innovative textiles, and one company from Italy, Frumart, contact me that they have developed a pineapple leather, which the composition was 50 waste of apples and 50% polyurethane. But they start with paper because in Alto Adige, there were lots of waste of apples from food industry where they make their marmalades and juices, and they don't know what to do with this waste, and they try first with paper. And we have even examples in some presentation how for example you start now. The problem, what I see in this leather is just that it's, let's say, it's one part is circular, and then you have the same problem in time, no, because it's a mixture with synthetics. So it is a problem what to do with the waste and how to recycle this kind of material. But it can be kind of solution, for example, in the sector of vegan leathers. Next slide. This dress is even made with apple skin leather. And here again, I want to show how you can work with this innovative textile in haute couture, and how to launch this kind of textiles to get as much as we can awareness of that, because the problem of a lot of designers is that or they don't know what exists on the market, or you have to buy 300 meters of a textile, small quantities, you are very limited then in design, because small quantities, of course, you have organic cotton, you have bamboo and so on, but these interesting materials, it's still quite difficult to get it if you are not a big brand. And how I see, let's say, evolution, of course, for me, it's very important to see that all your work is very important for us designers, because give us hope that we can not limitate our design, but we can develop designs that are ethical, that are sustainable, and that women can feel beautiful anyway. Next slide. I think that it's the end. Yes. That's it. Thank you.
Thank you, Matea. we are at the end of the presentations, but we are not finished yet, although we are running a little bit late, so we'll try to speed it up a little bit. But I think that in this, mixture of professionals and designers and creatives, I think that there were some great points, put on the table here, especially with the material resources and how to implement that into the sustainable fashion label, and of course the question of greenwashing. But first, I think that I would like to go to Uroš and have a discussion about the findings of your poll, because I think that it was very interesting to see that people, there were 10 participants, that they think that breathable and stretchable is the most important feature of the characteristics of the material. And the second one was self-cleaning, and recyclable was the third option. And here we are constantly talking about biomaterials. Either the recyclable is the last because we are using the word biomaterials, or do you think that what do you actually think
simple.
here? Why is the
There is always the simplest answer is the most correct. So
and that would be
yeah,
Practical, no?
so because it's the most convenient, you see young people now how they are wearing, what they are wearing, and what we are addressing are young people. We see the future, how they are behave. So for the design of the biomaterials, as Matteo Vendetti pointed out, yeah, they are cold. They're really cold. Yeah, this is something that we already know. So it's not that variable as, I don't know how this material is called, but it's like, the stretchable and breathable. I put it there just for the case. I didn't expect this would win, honestly, but still it's something that we need to work on as a scientist, develop the materials. So yeah, we have some ideas already, and this is something that we will now focus in the maybe next year or two, and maybe in the next meeting of that kind, we can show some progress in that regard. It's solvable, of course. It's not that it's impossible, but it's what us scientists love to do, take on the challenge.
Can I maybe tell you something here? We have to understand that not just young, everybody, we want to feel comfortable in clothes. We want that our skin breathes. That's the first and the most important thing. The last thing, you think about others, planet, and so on. So that's why it's so important what kind of material are the materials of the future, because more they will have this characteristic, more people will buy it. And more we will do good for the planet.
of course, first is our own comfort, and then
Yes.
we care about the global scale. It seems that way. And at ChemArts, you have the whole cookbook prepared. Piero, can you please tell more about the cookbook? What kind of things is this? The idea where you can basically get the inspiration and kind of start, the work yourself, and can this be the start of some self-production or?
I think the cookbook recipes that we are sharing are really for inspiration and for, like I mentioned, that this for people to get into these materials, to understand, to explore the properties, this flexibility, for example, how to make cellulose-based materials flexible. Of course, they are far from any to be used in fashion, for example. They are very, very far from these real life things. But the main thing, as I mentioned already, it's about inspiration and it's trying so that people get into these materials. Then we have some, of course, when we go really, for example, to solve the problem of lycra or these elastic materials that are really ruining everything that we try to chemically recycle, for example. So we definitely need new solutions for there. But that is something that is a little bit outside of our ChemArts activities. So it's mainly these scientists who are really working on those areas to really develop these materials to that level, and later on can then be again those findings can then be used by designers creatively later on. But we definitely need so-called hardcore science there to solve that kind of issues. But in general, I think that to understand what kind of properties can be in bio-based materials. So I think the ChemArts cookbook can bring some light there to open up the field.
Yeah, I agree. It has to start somewhere, and then, you know, we try to go from it. So this is kind of question for all of you, because you come from different backgrounds, you come from different institutions, and you've been working on different projects. How can institutions, schools, makerspaces, and individual researchers and designers help, especially young generation of, you know, inspiring innovators, and especially because we are a part of the Shemakes project, how we can inspire more women to become the innovators in this discipline? Where do you actually start? And you're free to if anyone has a comment, you can you know, just.
Well, I think that there is a lot of creativity and all of the inspiration that Pirjo was saying. So I think that the level of engagement somehow should be higher, in order to not to stay in the prototype level or not to stay in the idea level, but somehow to engage with the people so that they can make these projects theirs, and they can go further, step further with them. Sometimes the road to entrepreneurship is difficult, and we see that the models, the business models that we are used to, they are always requiring this startup mentality and the capital, venture capital, and all of these things. But I think there is a work that we can be done by also exploring alternative business models and pathways, and showing maybe that at the end, scaling up to mass production is not the solution that we want to give, but we want to really enable circular ecosystems that they can serve in first our needs in our surrounding, and then further maybe share with other creators, and see how this can be done in a peer-to-peer way. And I really like that the Paper and Pulp Institute said that they have this flexibility in the scale of, they can work with single designers, but they can work with bigger companies. And I think this is something that is not very common, especially when somebody wants to do innovation and goes to an industry. Probably the industry is not available to lose time for innovation, and that's somehow most of the times the limiting factor. And I think also what comes out from this panel, this conference, is that altogether we make this multidisciplinary landscape that if we put our skills together, like the Matteo, like with the fashion design, and then us with the education, and then the science, material scientists from the biomaterials and the paper, then all together we create this kind of ecosystem for innovation.
If I can say something on this, no? For example, because I am a professor too at the faculty, no? So I work a lot with students. I think when you develop some material that you can't go in production, do 1,000 meters, for example, no? It can be a middle step. Do some creative teams when you, for example, I love the example of the bag or something small, no? So that you make for people solutions that they can make it themselves or in this laboratory or whatever, but that they are very practical. Because if I check leather goods, it's one of the most polluted industry. If a woman do one bag with biomaterial, even there are some instruction how to make it, we done a lot, you know. So it can be like small custom-made or unique piece with innovation, and then industry is other part. But lots of people need this, because each woman needs 1, 2, 3, 10 bags. Why not one can be biodegradable and handmade and personal and so on? This can be, for example, one step in between, how I understand that these innovations don't stay, because the worst thing is that you do some innovation and nothing happens.
May I continue? Of course, it's about like you mentioned, that it's about prototyping, making demos, making small samples, and that's where this kind of a craft skills are also really necessary. So I very often think of also we need to look backwards and take some even old craft skills and use those especially in those steps, if we want to check if the material can be scaled up, or maybe we don't need to scale it up. Maybe it's like Anastasia said, that it can be just something that people can use or make themselves, for example, or it can be a very small scale production, possibly. So we need so many things in this network and this landscape to make this change in many different levels.
I also wanted to add something about this. This year, I was having a conversation about these topics with my students, and one of the questions that emerged was, why are we talking about this only at the final year of a master course? And this is actually, I think, something that institution can work on, because also in my experience as a student, I've never been involved in this kind of discussion and thinking. So I think that education should start from earlier steps to involve these topics of circularity, sustainability, material making, also from school, also before reaching the university level. And of course, in university, maybe hopefully not at the last year, but maybe from the beginning, and as a transversal topic that should encompass any other courses and design studios that the students need to face.
Uros, your hand is up.
Yes. So what we did, we know that we have to start with young people. So with Center Rock, we have developed the workshop testing the materials that we done with kids from 5 already. Our youngest, so as an institute, we don't have this formal, we're not like professors and so on. we take young entrepreneurs with good ideas. We are scouting them all around the world. And we invite them to work with us, with the interdisciplinary team, also with Igor. You know, you remember how many times we come to you, help us, give us something. And this is something that we are already working on for the past 5 years. There are some startups, there are some products. Still, we want to be more ambitious. And what we figured out, that when it comes to the, you know, from the innovation and to go, you know, to the real world, women are more scared than men. They're not that confident. So what's missing there? Why not that confident? So this is something that we want to do also to help them. We are doing different workshops to empower them. So last year we done one with 3 entrepreneurs. So this is what I see it's missing. It's the guys are like, yeah, okay, we will do it, and they do it. But for the females, I found out that they're like, I don't know, not that, you know, if they comes from the innovations, you know, the hub of the universities and so on, the market. As we see from the questions, you know, this is the real life questions that you are getting when you go to the market. So it's from the polls. So you saw that it's you're never good enough. That's the first point. We all know that. Not just females, also the scientists, you know, coming to the market. But yeah, if we share our experience and work in the team, all the entrepreneurs, all the youngest one, it's currently started with us working at 17. Now she's 19. She wants to work on the natural cosmetics. But what we give them is the contact to the science. As we are scientists, we can give them at least. So, but the end, it's up to them. We can just help them by the experience, connections, networking, and so on. But at the end, it's up to them. So far, we have 2 startups. The goal is that we help to co-create 1 startup a year. I hope that also during this event, we will get some contacts for some new ideas, new collaborations. So it's not just me, there are like a lot of people that work in my group. So this is what I want to share. So it's something that I just see from everyday perspective, working with young female entrepreneurs and students.
Pirjo, you had a comment.
Yeah, I had, because, you know, when you said that it's females are not so, don't trust themselves. It's really what I think here sometimes this startup culture is pretty male, you know, these digital things that you have this, you have to grow fast and you have to be overconfident, over self-confident to get things happening, and you have to be very quick and so, but it's not always best for, if we think of this material focused entrepreneurs who want to be, for example, funding has to be a little bit different, and they have to be supported to find the proper funding for and proper partners and coaches. It's not similar. It's different to develop an app than a material. So it's something we need to recognize as well, and find ways how to support those people, and also accept that everybody doesn't have to be like a unicorn type of entrepreneur. So there might be other ways to become an entrepreneur as well, in a sustainable way.
Yeah, the young generations do not want to be Elon Musk. They want to be engaged in the community, bring something to the community. And this is the new startups will be formed from our side. If they go bigger, they will sell technology, for example, to Slovenia or to other place. Okay, this is what now the global fashion industry is missing. You know, this touch to the community. They, you know, I will not explain more. You already know what I have in mind. So this is the feedback that I get from them. You know, don't be big, but be good for the community. Also, this is the conclusion with our goals. So this is something that everyone coming to our team has this in their mind. These goals, what we are trying to achieve. there's still a lot of money to earn also from that, what we are doing. So it's not that it needs to have billions.
In Shemakes, we built this somehow through also example of role models. So this knowledge transfer through role models that can serve as inspiration. I have this feeling that also within Shemakes, but also with the whole work in the Fabricademy network, that we are really trying to empower, and it's not about the gender divide, it's about the gender unite at the end, because we don't want to have separate things. We want to merge them to one, and to have more diversity and equality. And I think also it's not the black and white, male or female, but there is a full gradient in between that it's interesting to explore and to take into account. But I also believe that if inspirational stories from role models can help a lot in empowering this the new creatives that they come in this field.
Thank you. We are nearly at the end. Actually, it's already 7 o'clock, but I would still like to ask if from the audience, does anyone have a question for some of our lecturers, for our experts, or a comment about the topic we're discussing? I guess it's going to be quite quiet at the moment. But I do think that projects such as Shemakes can really make a difference, because there's a collective of different institutions, individuals, experts, and we are all, trying to achieve this common goal, and each of us are finding our own ways on how to approach, how to start the conversation, how to start with the support. And I think that today you all showed a variety of different knowledge and experiments and experiences that you can offer. And hopefully that today our goal was achieved, that we inspired the future generation of female and male innovators. And I would like to thank all of the guests, all of you to have given us these great presentations and were here with us. So a big thank you from my side.
Thank you to you.
Thank you.
Thank you.
Thank you all. It's been very inspiring also for me to hear the stories across the Europe. Thanks.
So thank you all. And with this, we can close the symposium of innovative biomaterials in design.
Yeah. Bye. Thank you. Bye.
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 Right.
Bye. Thank you.